of a parent graph. So the parent graphs, if you remember, there were 8 of them, and you need to memorize those. You need to know those 8. And so when it affects the appearance, it could move it up, down, left, or right. That's one way. It could also make it wider, narrower. Okay, and so we have names for those transformations. The first one is a rigid transformation. That's the one that changes only the position of the graph. That's the one that moves up, down, left, or right. Okay, a non-rigid transformation, that's the one that shrinks it, widens it, it distorts the shape of the graph. Okay, and so that's just what those are. I don't know if you're ever going to get tested on that, but what we're going to do is we're going to talk right now about vertical translations and horizontal translations. If you pay attention, these aren't tough. Okay, they're a little weird and they take a little bit of time to get down, but they're not tough. So first of all, let's talk about vertical translations. Okay, the equation you should probably write down is this, and we're going to talk a little bit about what that means. Okay, you take whatever your parent function is, and then you add a number. That's what a vertical translation does. Whatever your parent function is, and you add a number. Now, based on what that number is, that tells you what it should do. So I'm just going to do an example. If k is 4, you're going to go up 4. If k is -3, you're going to go down 3. So basically, it's whatever you see. That is with the vertical translation. Okay? A horizontal translation, on the other hand, is a little different because the translation is actually done within the parent graph. Okay? You see that little -h there. The translation is done within the parent graph. You are going to always use the opposite of h. You are always going to use the opposite of h. So example, if I had x minus 4, I'm actually going to go to the right 4. Yeah, positive 4, right. So to the right 4. Now, if I had x plus 3, I'm going to go to the left 3. So the vertical is exactly what you see. The horizontal is going to be the opposite of what you see for the translation that you do. So with that in mind, we're going to go ahead and look at this next slide. And we're going to just look at how you can graph using some translations. So if you look at this one, it says use the graph of f of x equals the absolute value of x to graph each function. So we start with an absolute value of b. Now, if I look at this, okay, is this going to be a vertical or a horizontal translation? Why? Exactly. This is on the outside, right, of the absolute value. It's separate. So since it's separate from the x, it's a vertical translation. Now with a vertical translation, we do whatever we're told. It says plus 4. So what am I going to do with my graph?
Oh, 4.
I'm going to go up 4. So there you go. That's what that graph looks like. Okay.
That's all you do.
That's all you do. So the pink is the final graph. Let's look at this one. So let's look at what is done. This is what's done, right? Is that a horizontal or a vertical? Horizontal. Horizontal. Horizontal, we do the opposite. So where am I going to go? Oh. I'm going to go to the left 3. So the blue is the original, the purple is the one we just got done doing, and then the pink. So that's all we do. Okay. That's both.
Okay.
It's both, exactly right. So let's think about that. What does this tell me I'm going to do?
So it's going to go up.
Two,
down 1, down 1, and up.
Down 1. So let's do the down 1 first. Okay.
And then over 2.
And then what does this tell me I do?
Right.
Plus, yeah, to right 2.
So this tells me I go to the right 2. So by breaking it down and doing them, right 2. By breaking them down and doing them one at a time, it's easier to do than if you tried to do them both at once. So that's the horizontal and vertical. Now what we're going to do is we're going to look at reflections. Now reflections are a little different. This is the last thing we're going to cover today. Okay. So first of all, reflection in the x-axis. When I think about reflection in the x-axis, I think about x-axis what? What is something we've learned about like this?
Well, or like Y's and the.
I know, what was it called? You're right.
Origins and
Symmetry.
Symmetry.
That's
Perfect.
the
Good
word.
job. Okay, so symmetry. And so basically, these are symmetrical graphs. And so if it's a reflection in the x-axis, all I do is negate the function as a whole. So example, y equals, let's do this, negative the absolute value of x. Okay, that would be an example. Now the reflection in the y-axis, on the other hand, is a little different, because let's look, what does it say you do? You negate what? You negate the x. So that's the difference between the two. Okay? And so when you think about that, it's kind of opposite. If you're reflected in the y, your x is going to be negative. If you're reflected in the x, the whole function, or in fact the y, is going to be negative. Okay. So with that in mind now, we're going to look at writing some equations. Yep. Got it written down? Nope. Okay. So reflected in the y means you change the x. Reflected in the x means that you negate that whole function. Yep. So now what we're going to do is we're going to look at the 5. It says describe how the graphs of f of x equals x squared and g of x are related. Then write an equation for g of x. So here we go. So there's your original function, right? Now I have to somehow get to the g of x function. And so first of all, I know that this is an f of x equals, actually I take that back, g of x equals x squared. So what do you do? What's the first thing I do to that purple to get the blue? Because I got a couple things. What'd you say?
Over 2.
Move it over to? Or move it over to about right here?
Yeah.
Okay, so I moved it over how far?
2.5.
To the right, about 2.5. So if I make a horizontal translation, what do I change? I change the x, right? And it is a positive 2.5, so what do I put down here? Negative 2.5. Okay. Now, how do I flip it? I flip over what one? The x. So that means I don't negate the x, I negate this instead. If it would have flipped over like the y, you would have put your negative inside. But there you go. That's the equation. Now, the nice thing about these is you could actually graph them and check and see if you're correct. If we graph this, we should get something to look just like the original graph.
Can we put that equation into our graphing calculator?
That's what I said, yeah. You could put this in, and you will see that it in fact is exactly like what we started with. So let's look at this next one here. And this isn't the easiest stuff in the world, so if it's still a little foggy, that's okay, because it was probably foggy for over half of you. It's just one of those things that takes some time. Okay, so we're starting with x squared again.
Go up.
So I can go up, okay? I can go up 2. So since it's a vertical translation, where do I put the 2? Outside, yep. And what do I write it as? Positive 2, yep.
Why
Okay,
do you go up to?
because that's where my vertex is. And then now what are you going to do?
Then flip it.
Then
So
flip it.
negate the x.
Mm-hmm. There you go. Okay. And so,
Why did you
Okay. So,
no. It's not going. It's going to be negative on the whole thing. It's going to be negative x squared on the whole thing because you're flipping it this way. You're not
Are you
flipping it
basing it off of
this
the
way.
purple one? Is that
Yep.
what you're starting
No,
with?
you're basing the purple one is where we started,
And you went up
and
2
we're
because
trying to
it
get to the blue.
You went up 2 because it was x squared?
Mhm.
Okay. And then where did the plus 2 come from?
The plus 2 came from because it was up 2.
Okay. And then what's the negative one?
The negative came from the fact that you had to flip it.
Okay, and that's what the upside down
Yep.
line is?
Yep.
Okay.
So when you go like horizontal,
Mhm.
then that's when you put the negative on the outside, right?
Yes. What do you mean horizontal?
Like
Like for instance, side to side.
Okay, we had to flip this upside down. We had to flip it over the X. When you flip it over at the X, you negate the whole thing.
Okay, and then when you
If
flip
you
it-
flip it over the Y, that's when you would negate the X and you would put it like this.
Okay.
Okay. And that does, it takes a while. So yeah,
Do you always start in the middle like that?
yes. And why we started that is because that's our parent graph. That is our original graph. Now the parent graphs are located, I believe it's on page 45 of your book. And so, let me double check real quick.
What are they like under the parent graph?
They are those 8 graphs that we looked at, if you remember, and I said these are the parent ones you're going to need to remember.
Oh.
Page 45 and 46, those are the ones that you're going to have a quiz over probably Tuesday or Wednesday, where you have to identify all 8. Remember, we had a constant, an identity, we had a squaring function, a cubic function, we had the absolute value, the greatest integer function. I'm missing 2.
The reciprocal.
Reciprocal and
quadratic.
the quadratic, yeah. So those are what you're going to have to file away. Now, let's go ahead and look at this one. This is along the same line. This is the reciprocal function. This is what the original reciprocal function looks like. This is on page 45. Okay? And so the original reciprocal function is this. And if not, you could have graphed 1 over x as well on your calculator and it would have showed you. So first of all, let's think about things. Let's do our flip first of all, because I think that would be easier. So I flipped it, right? And in this case, it doesn't matter what I negate because it's still going to be the same. So the negative takes care of the flipping. So instead of having what I have right now, since I've now flipped it with the negative, this is what I have. So what do I need to do? Move it. So here's where I initially started at, right, with my asymptote. Where's my new asymptote at?
-2.
-2, good. So I've went down 2. How do you do a down 2?
-2.
-2. Remember, you just subtract 2 on the very end.
And so the -1 over x comes from you flipping?
Yep. 1 over x is where we start. The negative is what we flip it. Okay. So let's do this one. I start with this, right? What am I going to start by doing?
Flipping?
Flipping it. So it becomes -1 over x. So instead of being that, it's now going to be, it's going to be this. But it still doesn't quite match up to that blue, so we have to figure out how far do I move it. So here's where my asymptote is now. Where's the asymptote on the original blue one? Yep. 1, 2, 3, 4. So I've moved it left 4. Now this is a horizontal, so do I write it this way?
Do it on the inside of the
I do it on the inside of the parentheses, and since there's none there, I'm going to have to put some in. So parentheses,
negative.
x
Minus
plus
4.
4. Good job, you caught that, because it's, remember, it's always the opposite. And once again, if you wanted to, you could always graph this on your calculator and check it to see if you've done it correctly. Yeah. You just kind of have to look and see what it doesn't cross. Okay, if you didn't catch that, was how do you know which one is the asymptote? Well, I'm going to have to look here. If I look at 3, I see that 3 is already crossed right here. So if I look at -5, I see that -5 is crossed right here. So obviously the only one in between would be the -4. And it just takes practice. I mean, it's going to be something that's probably right now a little bit fuzzy. Okay, but this is your assignment. I need you to do 1 through 6, which you already should have. And then I need you to add 8 through 30 to evens.
Wow, 32 or 40?
No, 8 through 30 to evens.
Are we
So-
gonna check this or are we just handing it in?
So that's what I need you to work on. Yeah, well, I'd like you to probably get a good start because we are going on tomorrow. Okay. but I know there are some activities, so I don't want you staying up till 2 and 3 in the morning doing your math.
I would
I've not been okay with it.